Are your SQL databases drowning under millions of queries? Are slow reads and bottlenecked writes keeping you up at night? Well, you're in the right place. In today's video, we're diving into the secrets of SQL scaling, focusing on two game-changing strategies: read replicas and write partitioning. Stay tuned, because solving these challenges can transform you into a system design superstar. SQL databases are the lifeline of any application. But as your user base grows, so does the pressure on your database. Slow response times, read-write contention, and even outright crashes. These are every developer's nightmare. So how do the big guns, companies like Google, Meta, and Amazon, keep their databases lightning fast at scale? Two words: read replicas and write partitioning. Let's start with read replicas. Imagine your app is a bustling coffee shop and your database is the lone barista handling all orders, reads and writes. Overwhelmed, right? Enter read replicas, your team of supporting baristas. Simply put, a read replica is a copy of your primary database that handles read-only queries. It offloads the read traffic, leaving the primary database to focus on writes. But here's the catch: replicas lag behind the primary database because of replication delay. So if you're building something like a stock trading platform, this might not be ideal. But for apps with read-heavy workloads, think blogs, e-commerce stores, or news feeds, it's a lifesaver. Punchline: why make one database work overtime when you can delegate and scale like a boss? Want more insights on replication strategies? Smash that subscribe button. Now let's talk about write partitioning, also known as sharding. Think of it as splitting your database into smaller, more manageable pieces, each responsible for a subset of data. For example, imagine you're running a global social network. Instead of storing all user data in one database, you can partition by region. One shard for North America, another for Europe, and so on. This approach spreads out the write load and prevents a single point of failure. But here's the pro tip: always choose a partitioning key wisely. A poor choice can lead to hotspots, where one shard takes most of the traffic while others sit idle. Partition like a pro, or prepare for chaos. Does sharding sound intimidating? Don't worry, we'll break it down further in the next video. Subscribe to stay ahead of the game. So which strategy should you use? It depends on your use case. If reads dominate, go for read replicas. If writes are the bottleneck, write partitioning is your best friend. Scaling isn't one size fits all, it's about picking the right tool for the job. SQL scaling is the secret sauce behind the world's most robust applications, and you've just unlocked two of its most powerful ingredients. But this is just the beginning. We'll explore more scaling strategies like caching, load balancing, and NoSQL solutions in upcoming videos. So, what are you waiting for? Like the video, subscribe to the channel, hit that bell icon to never miss an update. Because mastering system design isn't just about writing code, it's about designing for the future.
NoSQL databases demystified: types, use cases, and best practices.
Are you still trying to use relational databases for everything? Well, the world of NoSQL databases is here to show you there's more to life than tables and joins. In this video, I'll break down 1. The 4 main types of NoSQL databases, 2. When and why to choose NoSQL over traditional SQL, and 3. Best practices to design scalable, efficient systems with NoSQL. If you're ready to future-proof your database knowledge and elevate your system design game, let's dive in.
NoSQL databases are non-relational databases designed for modern applications that demand high scalability, flexibility, and speed. Unlike SQL, which relies on structured schemas, NoSQL databases embrace a more dynamic approach to handle unstructured or semi-structured data. NoSQL is ideal for big data, real-time analytics, and applications that prioritize speed over strict consistency.
NoSQL isn't a one-size-fits-all solution. Let's explore the 4 main types. 1. Key value stores, best for caching, session management, and real-time data. Examples: Redis, DynamoDB. 2. Document stores, great for content management systems and e-commerce platforms. Examples: MongoDB, Couchbase. 3. Column family stores, perfect for time series data and analytics. Examples: Cassandra HBase. 4. Graph databases, ideal for social networks and recommendation engines. Examples: Neo4j, ArangoDB. From simple key-value pairs to complex graph relationships, NoSQL has a database for every need.
Deciding between SQL and NoSQL depends on your application's requirements. Choose NoSQL when 1. You need horizontal scalability to handle massive loads. 2. Your data is unstructured or semi-structured. 3. Real-time performance is a priority, like in gaming or IoT applications. 4. You require flexible schemas that evolve with your app. But remember, NoSQL sacrifices strict consistency for scalability, so it's not ideal for transactional systems like banking.
Where does NoSQL shine in the real world? Key value stores Redis powers real-time leaderboards in gaming. Document stores MongoDB is used for flexible e-commerce catalogs. Column family stores Cassandra handles billions of time series records for monitoring systems. Graph databases Neo4j powers recommendation engines like people you may know on social platforms. NoSQL isn't just a buzzword, it's the backbone of the apps you use every day.
NoSQL isn't perfect. Here are some challenges. 1. Consistency issues. Most NoSQL systems follow eventual consistency, which may not suit critical apps. 2. Query complexity. Advanced queries can be harder without SQL's structured syntax. 3. Learning curve. Each NoSQL type has unique features and limitations. The key is understanding these trade-offs and choosing the right database for your workload.
Here are my pro tips for leveraging NoSQL effectively. 1. Understand your use case. Match the database type to your application's needs. 2. Embrace horizontal scaling. Design your architecture to add nodes seamlessly. 3. Monitor performance. Use tools to track replication lag and query speed. 4. Optimize indexing. Especially in document stores, indexing can make or break performance. Using NoSQL isn't about ditching SQL, it's about picking the right tool for the job.
To recap 1, NoSQL databases come in 4 flavors: key value document, column family, and graph. 2, they're ideal for unstructured data, high scalability, and real-time performance. 3, mastering NoSQL requires understanding its trade-offs and matching the right type to your use case. In our next episode, we'll tackle event sourcing and distributed systems. Don't miss it.
If you're ready to unlock the full potential of NoSQL databases and build systems that scale effortlessly, hit subscribe, turn on notifications, and join me for the next deep dive. Because in the world of modern databases, the future isn't relational, it's flexible.
Subscribe to Hustler Coder, NoSQL, demystified new videos every week.
Cache invalidation, the art of staying fresh. Boost your system performance today. What's harder than solving a tough system design interview question? Answer cache invalidation. As developers, we all know caching can speed up applications dramatically, but how do you ensure that the data in your cache stays fresh and accurate without slowing down your system? In today's video, I'll break down 1. The challenges of cache invalidation, 2. The top strategies to solve them, and 3. Best practices to keep your systems fast and consistent. If you're ready to crack one of the hardest problems in computer science, let's dive in. Caching improves performance by storing frequently accessed data closer to the user. But when the underlying data changes, the cache can become stale, leading to incorrect or outdated results. Why is this critical? User experience. Imagine an e-commerce website showing wrong prices. System integrity stale data can cause errors or conflicts in your application. This is where cache invalidation strategies come into play to ensure that your cached data stays as reliable as your system. Let's face it, cache invalidation is hard. Why? Timing issues. How do you know when the cache should expire? Distributed systems synchronizing caches across multiple servers can get messy. Trade-offs. You're always balancing between speed, consistency, and complexity. Managing caches isn't just about storing data, it's about keeping it in sync without breaking a sweat. Here are the top 3 strategies for cache invalidation. 1. Time-based expiry, also known as TTL. Set a time to live for each cached item. Once the TTL expires, the cache is invalidated. The pros? It's simple and effective for frequently changing data. The cons? You might encounter stale data during the TTL period. 2. Write-through or write-back caching. Update or invalidate the cache every time the underlying data changes. This ensures data consistency, however, it comes with higher write latency and complexity. 3. Event-driven invalidation. Use events to notify caches when data changes. This allows for real-time updates with no staleness. But it's complex to implement, especially in distributed systems. Where are these strategies used in the real world? Time-based expiry is popular in content delivery networks like Akamai or Cloudflare. Write-through caching is widely used in relational databases with cache layers like Redis. Event-driven invalidation is essential for real-time systems, such as stock trading platforms or collaborative tools like Google Docs. No matter the system, the right cache invalidation strategy makes the difference between smooth performance and a meltdown. Here are some best practices to ensure smooth cache invalidation. First, understand your data patterns. Know how often your data changes and who accesses it. Second, choose the right cache type. Use in-memory caches like Redis for speed and distributed caches for scale. Third, combine strategies. Use TTL for some data and event-driven invalidation for others. And finally, monitor cache performance. Keep an eye on hit rates, latency, and staleness. My pro tips for mastering cache invalidation. 1. Test for edge cases. Always test how your cache handles stale data during high traffic. 2. Automate expiry. Use tools or scripts to manage time to live and invalidation events. 3. Keep it simple. Sometimes a simple time to live works better than a complex solution. Cache invalidation isn't about perfection, it's about making smart trade-offs for your use case. To recap: 1. Cache invalidation is essential to maintain system performance and data consistency. 2. Time-based expiry, write-through, and event-driven invalidation are the top strategies. 3. Choosing the right strategy and combining them when necessary is the key to success. In our next video, we'll explore distributed cache design. Don't miss it! If you're ready to design systems that are fast, consistent, and scalable, hit subscribe, turn on notifications, and join me for the next episode. Because in the world of system design, the difference between slow and fast often lies in the cache. Subscribe to Hustler Coder, Cache Invalidation Simplified, new videos every week.
Redis cache layer designed like a pro. Boost speed/latency, master performance. Is your application struggling with slow response times and database overload? Enter Redis, the in-memory powerhouse that can turbocharge your system's performance. In this video, I'll guide you through how to design a Redis-based cache layer for blazing fast performance, key caching patterns and when to use them, and best practices to avoid common pitfalls. If you want to design systems that are both fast and scalable, let's jump right in. Redis isn't just a cache, it's a blazing fast in-memory data store trusted by companies like Netflix, Twitter, and Pinterest. Why Redis? Lightning fast speed. Data is stored in memory, not on disk. Versatility, supports strings, hashes, lists, sets, and more. Simplicity, easy to integrate into any tech stack. If your application needs low latency and high throughput, Redis is your go-to solution. Redis isn't just a buzzword, it solves real-world problems. Caching frequently accessed data to reduce database load. Session management for user authentication. Rate limiting for APIs to prevent abuse. Leaderboards and real-time analytics in gaming or e-commerce. From user sessions to real-time dashboards, Redis is the Swiss Army knife of caching. Designing a Redis-based cache layer starts with understanding caching patterns. Here are the top 3. 1. Cache aside, also known as lazy loading. The application checks the cache first. If the data isn't there, it fetches from the database and stores it in the cache. This is best for read-heavy workloads. 2. Write-through. Data is written to the cache and database simultaneously. This ensures cache and database consistency. 3. Write-behind. Writes go to the cache first and are asynchronously pushed to the database. This is best for reducing database write latency. Choosing the right pattern depends on your application's read-write balance and consistency needs. Let's break down the architecture. 1. Redis instances. Redis nodes act as the cache layer sitting between your application and database. 2. Key design decisions. Choose time to live TTL values, eviction policies, and cache partitioning. 3. Integration. Use Redis clients like Redis or Jedis in Java or Redis Pi in Python. Designing your Redis layer isn't just about speed, it's about smart decisions that scale. Even with Redis, caching has its challenges. 1. Cache misses. When the cache doesn't have the data, resulting in a fallback to the database. 2. Stale data. Cached data can become outdated. Use TTLs and invalidation strategies to mitigate this. 3. Cache stampede. A flood of requests to rebuild the cache when it expires. Solve this with locking mechanisms or staggered TTLs. Here's how Redis is used in the real world. Netflix caches frequently watched movies for instant playback. Uber uses Redis for geolocation data and ride matching. GitHub caches API responses for faster UI rendering. From streaming to ride sharing, Redis powers the services you use every day. Here are the best practices for designing a Redis-based cache layer. First, set expiry times. Always define TTLs to avoid memory bloat. Second, eviction policies. Use strategies like LRU, or least recently used, to manage memory effectively. Third, monitor performance. Use tools like Redis Insight to track hit rates and latency. And finally, use sharding. Distribute keys across multiple Redis nodes for scalability. My pro tips for Redis caching. 1. Use a key naming convention. Make keys descriptive to simplify debugging. 2. Avoid overcaching. Cache only what's necessary to prevent waste. 3. Combine with other layers. Pair Redis with a CDN or database index for optimal performance. A well-designed cache isn't just fast, it's a lifesaver for your entire system. To recap, 1. Redis is a versatile, high-performance in-memory store ideal for caching. 2. Caching patterns like cache aside, write through, and write behind ensure flexibility and efficiency. 3. Best practices and thoughtful design are the keys to unlocking Redis's full potential. In our next episode, we'll explore distributed caching with Redis Cluster. Don't miss it. If you're ready to speed up your applications and design systems that scale effortlessly, hit subscribe, turn on notifications, and join me for the next episode. Because in the world of system design, speed isn't just an advantage, it's a necessity. Subscribe to Hustler Coder Redis Caching Simplified, new videos every week.